Okay, guys, so now I want to talk to you guys about kinematic formulas, okay? These four formulas here are super important for us, okay? So now when we're doing all of our one-dimensional motion problems, we can use a lot of the times these little formulas to find acceleration or velocity, right? Or displacement, all of these things. We can use all of these little formulas, but these four formulas right here are going to have a really big impact on the way that we can solve problems. So, for example, if you kind of look through these, they're all a little bit simple and straightforward. Let's say I start at a certain velocity and then I accelerate for a certain number of seconds. That can tell me my new velocity, right? So that'll be something like this first formula right here. This second one is just my average displacement, or sorry, my total displacement. It's just my average velocity. You know, you have two numbers, add them together and divide by 2. That's an average, right? Times time. So pretty much how fast was I going and how along did I go that speed? That'll give me how far I traveled, right? So my displacement. So these are all kind of simple and straightforward to play around with. But the important thing here that I want you guys to focus on, okay, after you've gone through the slides and you kind of look through a little bit of the theory, I want to talk to you guys about how we use these, okay? So all of these kind of have the same ingredients, right? They all have initial velocity, final velocity, displacement, acceleration, time. They have all of these things in them. Let me go ahead and put little vector symbols here. I messed that up. Okay, something like that. Don't forget that, just to remind us that these are vectors. So why would I have four formulas for you guys that have the same pieces just kind of shuffled around? You know, why would we do that instead of just giving you guys one formula that's, let's say, had them all combined and you guys just have to remember one thing and that's it? So the reason why we're doing this is actually because we have 5 different pieces of motion, 5 different pieces of information that'll describe pretty much any type of motion if we have constant acceleration, right? So a bunch of stuff. It's really powerful. But if I had one formula that had all 5 of these things, then I would need to know 4 of these things in order to find the 5th one. Remember, one of our rules for algebra, if I say x is equal to something, nothing else can be unknown. I have to give you all of the information except for x in order for you to solve for x, right? In order for us to have a unique solution. So when we do this for our kinematic formula, what we're going to do is we're going to chop these up and shuffle them around, and then something interesting is going to happen. So what I want to do with you guys is kind of walk you through a little bit about the ingredients in each of these kinematic formulas, and that'll kind of explain to you guys how to use them, right? So this first formula right here, if I take a look at what the pieces are, it has final velocity, initial velocity, acceleration, and time. Let me go ahead and use another color here. This one right here. So I have initial velocity, okay? I have final velocity, I have acceleration, and I have time. All of these things are in my formula, okay? But there's no displacement. Okay, that's good. Let's go and move on and see our second formula. I have displacement, initial velocity, final velocity, and time. Okay, so let's kind of fill these in here. I do have initial velocity. I do have final velocity. I do have displacement this time. Okay, that's nice. This is good. I don't have acceleration here, but I do have time. All right, great. Now going on to my third formula here. If I look through it, I do have initial velocity. It's in there. I don't have final velocity. Okay, that's fine. But I do have displacement. It's right there at the beginning. I have acceleration. Good. And I have time. I have time twice in here. Okay. And then my last formula right here, you guys can maybe start to see a little bit of the pattern here, but I also have initial velocity in this formula. I have final velocity, I have displacement, I have acceleration, but I do not have time. Okay, so let's kind of look through what we have done here. Is in my first formula, I do not have displacement. In my second one, I don't have acceleration. In my third, I don't have final velocity. And in my fourth, I don't have time. So this is good because each one of these only has 4 out of the 5 pieces, right? So because it only has 4 out of the 5 pieces, now I've made this much easier to where I only need 3 pieces of information, right? So here, let me go and write this out. 3. Now I'm gonna put pieces. What I'm gonna put is variables. Okay. 3 variables needed to solve a kinematic formula. But here, the interesting thing is pretty much any 3 pieces of information will let me use one of these formulas, right? So they all have initial velocity, that's fine. But when I look at a problem, it depends on, do I know the final velocity, right? Do I know where the velocity ended? Okay. Do I know its displacement? Do I know its acceleration? Do I know its time, right? So a good strategy for you guys to do on all of your problems when you're trying to solve these formulas, or sorry, solve these problems, is you make a list, right? So here I would make a list of my variables. Let's say I would say initial velocity, final velocity, acceleration, displacement, and time. I would just make a little list on the side, let's say the left side of my problem or something like that. And then I would start to fill in the blank here, right? Do I know what this is? Do I know what this is? And I would start to write down from the question, which one of these variables do I know? Okay. And most of the time, especially in the beginning, it'll be kind of easy to fill these in. Okay. To fill in at least 3. Once you have 3, don't worry about the others. Let's say I have initial velocity, final velocity, and acceleration. If I have these 3 things and I'm trying to find a 4th thing, let's say I'm trying to find, let me change here. Let's say I'm trying to find displacement. So I know this, and this, and I'm trying to find displacement. What I need to do is I need to look for a formula that has these 4 pieces. I don't care about time because I don't know it. I don't know what it is, but also I'm not looking for it. So I can just pretend time doesn't exist for this problem. So I only need these 4. So I'll look for a formula that has all 4 of these parts, and that's the one that I will use. So pretty much, let's see here, initial, final, acceleration, displacement looks like formula number 4, initial, final, acceleration, and displacement. I have all 4 of these pieces here. It doesn't have time, but that's okay. I don't know time and I'm not looking for it, so I don't need it, okay? So this makes it way easier to kind of work with these problems. But the best way really for us guys is to just practice these. So you're going to have a little bit of practice in the beginning with doing problems with trying to find out what are my variables, and trying to fill them in. This is kind of the hard part, and the main part of physics is trying to lay out and organize our information. But once you guys get this, the math that we're doing is not going to be hard. One thing that I want to show you guys here just right before we end is I actually have another form here of formula number 3. So formula number 3, you'll see I had these 2 time. I had time and time squared. So this is fine. All of these other ones, if I can solve them to get something by itself, then I can find that thing. Let's say in formula number 1, if I'm looking for time, I need time to be by itself on one side of the formula. That's easy. I'll subtract both sides by initial velocity to get that to the other side, divide by acceleration to get that by the other side, and it'll have time by itself. But this time and this time here makes this kind of tricky. So what I've done here is I've kind of already shuffled this around for you. You guys can write this down, keep this in your notes. This is an alternate version of equation number 3 in case you need to find time. It's already shuffled for you according to this quadratic formula. So you guys don't have to do this every time, because even when I have to do this, it takes a little bit of work, right? And that's it, guys. So we've got our kinematic formulas, and we can start now to do some examples of different types of motion, one-dimensional motion, that will help us get a grasp on which formula to use and when. So we'll be doing that next.